Hey guys, welcome back. Today we're going to talk about finding volumes by revolutions. And this might be a difficult one for me to teach via this method, so wish me luck. I really hope you watched the two videos that I posted from YouTube because they have better graphics than I do. So, all right, we're going to start with this curve, y equals the square root of x, which you should know, and visualize that there's a shaded region between the curve and the x-axis. We're going to then rotate that shaded region around the x-axis. So we're going to rotate that shaded region around the x-axis and create what kind of looks like a bullet. Okay, so that's what we're creating. Now, to be honest with you, you don't have to be able to visualize the shapes necessarily to know how to do this. But if we rotate this area around the x-axis, we're going to get that bullet looking thing, okay? So now how do we find the volume of it? Well, if you visualize this bullet and you imagine slicing it in different slices like this and pull that slice out, what shape would that slice be? Okay, hopefully you can see that it would be a circle. So we have a bunch of circular discs going across here. We're going to add up all of those circular discs. So we're going to find the volume of one disc, okay? And then, since it'll be in terms of x, when we find the volume of all these discs, they'll all be different sized discs. This one's small, this one's big, but they're all going to be in terms of x, so the different values of x along the x-axis will take into account that they're all different sizes. So the short of it is we're going to find the volume of one disc, and then we will add up all of the discs by integrating. So back up a little. How do you find the volume of one disc? Well, it's the area of the circle, if it were flat, which would be pi r squared, okay? And then that's just the area of the circle, so to give it width, we multiply by an infinitely thin width. We call that dx, okay? So basically it's going to be the area of a circle. To make it the volume of that circle, we give it width right here. That would be the volume of one disc. And then to add up all the discs, we integrate. Okay, now the only thing that's weird, and we're going to integrate from this one from 0 to 4. Okay, the only thing that's weird here is it's not really pi r squared. We've got to write r in terms of x. So what would that r be? The radius is going to be the radius of the circle. Remember, the radius of the circle would go from here to here. So it always ends up being the distance from the curve to the axis of rotation. So that distance is the square root of x minus 0, or just the square root of x. So this becomes pi times r squared, where r is the square root of x minus 0, or the square root of x. Okay? Now, we'll worry about the computation of that in a minute, but let me try to explain again why you can find the volume of a solid figure by doing this. Okay? We're getting the area of one circular disc. Start with the area of one circular disc, and that's always going to be pi r squared, because it's a circle. Okay? Multiplying by dx gives it an infinitely thin width, and that turns it into the volume of one disc. Then integrating adds up all of the discs going across. Okay? And that's your basic formula for volumes by revolution. Okay? So now let's do the math. And by the way, it's always going to be pi r squared, where r is the distance from the curve to the axis of rotation. All right. Now let's do the math. Squaring a square root, that'll give us just x. Okay, now we're going to integrate it. Pi, you could move the pi out front if you wanted to because it's a constant, so it doesn't have to stay there. But this is just going to be a power rule. So when I integrate, I get pi x squared over 2, evaluated from 0 to 4. Plug in the 4, plug in the 0, and subtract. Plugging in the 4, I would get 16 over 2, which is 8 pi. Plugging in the 0, I get 0. So my answer is just 8 pi. Okay, so your general formula is find the area of one circular disc, okay? Change it to volume by multiplying by its infinitely thin width, and then integrate to add them all up. All right, let's try another one. Here's a summary of the formula. It's going to be pi r squared every time. The pi can go in front, makes it maybe a little easier, okay? Make sure whatever r is, you put it in parentheses and then square. So let's try it again. Here we go. All right, this time you want to graph it on your own without a calculator. Visualize what it looks like, okay? This is a negative parabola. Maybe find the x-intercepts of that parabola. Okay, I'll pause while you find the x-intercepts and graph that parabola. So if they don't give you the shaded region, if they don't give you the picture, then you have to make sure you draw it, okay? And it's got to be pretty decent. So this is a negative parabola. So it's going to be, and it has x-intercepts at 0 and 4. It's a negative parabola, okay? And then we want the region bounded by that curve and the y equals 0, which is your x-axis. So this is the region we're talking about. That's the region that we're going to be rotating around the x-axis. Now, if you want to try to visualize what it looks like, if we rotate it over here, okay, and try to visualize that, you're going to get circles that this kind of looks like an egg. It's sort of an egg shape, okay? Again, you don't really have to know what it looks like in order to do this. All right, let me clean this up. Again, this is 0 and 4. Okay, so volume equals pi r squared, okay, where r is always the distance from the curve to the axis of rotation, and this is the curve. So it's the distance from that to 0. Okay, and then we're going to integrate, add up all the circles that are going across, and we would integrate from 0 to 4. Okay? Again, the full volume would be the other half of this. The circles actually go all the way across like this, but the radius is just half of that. So the radius goes from the curve to the axis of rotation. That's what this is. Okay, now you could FOIL this out and do it by hand, a simple power rule, but you can also put it in your calculator. If you do put it in your calculator, then leave the pi in your answer. So go ahead and try that right now doing Math 9. Make sure you remember how to do that with your calculator. Okay, so I want you to make sure you practice using your calculator and still write your answer as a fraction and leave it in terms of pi as well. So you need to make sure you add extra parentheses here so that you can square. It really takes practice knowing how to use your calculator and use it quickly. Your final answer should be 512/15 pi, okay? Same thing you would get by doing it by hand, all right? So let's try another one. Okay, first graph this, make sure you know what region they're talking about, okay? I'll hit pause while you graph it and shade the shaded region that you're going to revolve. Okay, you have to be very careful about the vertical and horizontal lines and getting your shaded region right, because it's a completely different answer and a completely different question if you don't shade the right region. So we have my parabola. Now I want the line x equals 3. That's a vertical line through the x-axis at 3. And y equals 0, which is the x-axis. So the shaded region we're talking about is this guy right here, okay? So this we're not going to need. Now, if we revolve that around the x-axis, here's the mirror image of it, then our circular discs are going to go like this, little circles to big circles. Kind of looks like a Hershey's Kiss on the side, okay? So let me clean that up again. See if you can do the formula on your own. Pi r squared, you got this. Give it a shot. Okay, volume equals pi times r squared, okay? All right, what is r? R is the distance from the curve to the axis of rotation. So that's x squared to 0, which is just x squared. Integrate from small circle over. We're going to integrate from 0 to 3. And that's that. Simplify it, and then let's do this one by hand. Okay, square the x squared, you get x to the 4th. Now keep track of what this integral means. It means we still haven't integrated, so now I have to integrate. You get x to the 5th over 5. The pi can be out in front of parentheses, or with each term it works the same either way. Totally up to you how you want to treat that pi. So now I'm going to leave the pi out front, and I'm going to plug in my 3. 3 to the 5th, oh that's fun. 81 times 3, 243. Minus 0. So So my answer should be 243 fifths. Oops, not fifths. I got to change that, cube that also. It's 125. Okay, pi. I think that's my final answer, but I'm going to hit pause and check my math just to be sure. Yeah, I was distracted by I don't know if you guys could hear all the equipment going on around here, but I don't know what I was talking about with that 125. I'm not cubing that. I just lost my mind. So back to here. This should not be a 125. I should have just plugged in a 3. I don't know what I was even thinking. I thought it was a cube. I lost my train of thought. So plugging in a 3 right here, I definitely should have gotten 243 fifths. So 243 over 5. And then plugging in the 0, you get 0 and tack on a pi. That should be your final answer. Okay, so good luck, guys. Remember, draw a picture of each one. And please, please, please give this assignment your whole heart. Don't skip any of them. Make sure you understand every single problem, because we're doing more with this tomorrow and it's going to get a little harder, okay? Let me know if you need me to work out any videos. Bye. Good luck.